Hey, hello, and welcome to the show. I'm John Park, and this is Show and Tell. Thanks for stopping by. We are here to show off some projects that people are working on in the community. We have Adafruit person and a couple of community people. But if you want to join, there's still time. You can just head on over to the Adafruit blog, and you'll see a link there to our StreamYard, which is where we're hosting this. And all you need to do is give your web browser permission to use your camera and your microphone and maybe share a screen, and you can show us what you're working on. Also, if you want to go and join into the chat, head on over to the adafru.it/discord, and that'll get you an instant invite over to our Discord server. Look for the live broadcast chat channel there. And we also have chat up from YouTube. And I see a hello from Fernando Gonzalez Cid, who says hi from Argentina. And I say congratulations on that amazing win today over England in the World Cup. Great game, exciting finish. So also thanks to Charles Burnford for stopping by, and Trash Bandicoot. And over in the Discord chat, Paul Cutler and Due Wester, Todd Bott, howdy. Thanks for joining us. So first off, we have our very own Erin St Blaine to show us some stuff she's working on. Hey, Erin.
Hello. So I have kind of a cool project I've been working on this week. I'm just about to launch the tutorial. It should be up in a day or two. But I made a light up bubble wand. Ooh. So it's a 3D printed wand. I've got a little button on the handle here that lights up the LEDs. Cool. What's inside is a cool USB battery. This is going to last forever. This is going to power the 27 lights for like 6 years, I think. Rechargeable. It's got an onboard on-off switch, so it's a pretty simple build. Basically, inside the handle is this thing. Plus, I have a mini sparkle motion board, and then I'm using the seed pixels, and that's all there is to it. You just kind of plug them in and stick them in the 3D printed thing. And I have a little video that I can show if you want to show my share of a let's see if I can get it up here and play it. You can kind of take a look and see what it looks like when it's going. Cool. It makes bubbles just pop, like I guess. Really neat. A lot of cool tricks you can do. I designed this the wand in Onshape, and it's got a lot of little channels to hold bubble juice. So it seems to hold just a ton of bubble juice when you dip it. It'll hold a lot of stuff, and we were able to do a ton of tricks.
So are those like circular grooves that run inside of the
so they're not circular. It's just let's see. Let me give it back up. It's just little there you go. You can kind of see just little grooves that go around the thing, and the LED juice or the bubble juice just like soaks in there. So
neat.
Yeah.
I didn't know. Yeah, I didn't know you could do that. That's pretty cool.
Yeah, it's kind of fun. There's a lot of 3D printable bubble wand out there. And this one I designed to fit the electronics inside the handle and everything.
Yeah. So that's great. I like that. Yeah, I like your battery solution. Nice and simple. And it looks like you're using one of those flat USB connectors to keep it small.
Yeah, it's really neat. And it's just, they you can get these in the shop, and they just tiny little USB. They're just exactly right to just bypass this battery, and I can keep the handle really, really tight so nothing rattles around in there.
Yeah, that's great. Really cool build. And are you putting together a guide for this now?
Yeah, it should be live within a couple days.
Oh, awesome. Great.
Yeah.
Very cool. Thanks for sharing that. Now, do you have any bonus content for us today?
I thought I heard a rumor. Today,
you do?
Fact. Yes. I have a friend here who's working on some prosthetic application. She's coming up with a design, I think, for the Labyrinth Ball, which is in August down in LA. And Kate, you want to come over here and show everybody what you're working on? She looks amazing. She's been over there in the corner working on this all morning.
Oh, yes. Amazing.
She made the horns. What are they? They're millinery wire, is that right?
No, these ones. So the base of the horns is a latex that's molded to my head model. So this is all done on the custom head. And then the horns just have a bubble wrap inside and some wire to give them shape. And then this is called the heart clay. It's a very light clay that retains its flexibility after it's dried up. And then these guys, Erin can touch them. They're really squishy. Yeah. So these are silicone prosthetics that I designed and built, and there's a
Oh, wow.
plastic eyes that match my color eyes incorporated in it, and then the rest is paint here. So,
Amazing.
We're gonna go do a photo shoot in a little bit. So
Oh, that's great. Well,
yeah.
Thanks for sharing that. It looks amazing. All right.
So
Thanks so much, Erin. We'll talk to you soon.
All right.
Oh, amazing. I need some horns. Okay, so next up we've got Toddbot. Bring you onto the stage. Whoops, there we go. Hey, Todd.
Hey,
what do you got there?
So this is a little cutie pie running off a single AA battery. Sorry, AAA battery. From and the magic is this. God dang it, mirrored. Is this little board here? Yeah. So this little board is this little board. And it's a boost converter that goes from there we go. It'll go from 1.1 volts or so up to either 5 volts or 3.3 volts. There's two different ones. This is one that's going up to 3.3 volts, just going into the 3 volt input of the cutie pie or the Zhao cutie pie. Yeah. And you get these off Amazon or Alibaba, and they come in like a plate of 10 or so.
Oh, right.
And so they're really cheap. They're like, I think the whole chunk of them was like maybe $6 or something. So if you want to run your project off of a single battery.
Yeah, I do. I like that. That's a really good idea.
But yeah, so that's like the first thing. I have a second little thing, and that's I'm working on. I do a lot of MIDI.
Can I ask you a question? Sorry, before you move on. So with the boost converter going, what's in that direction? Is it fairly efficient? Are you getting pretty good life out of like an alkaline battery?
There can be efficient ones. So I think the best efficiencies are around like 90%. I think these are around 85 or 80% efficient, and you should be aware that like it's the power that's being translated. So if you're drawing 10 milliamps on at like 3 volts on your cutie pie, that would correspond to like 3 times that at 1 volt, because the power has to be the same. So you're going to end up draining a single battery faster than you would if you had like multiple batteries or whatever.
Right.
But it's if you use a lot of nickel metal hydride batteries like I do, you can just pop them in the charger, and those are a little bit safer than the lithium ion batteries.
Yeah. I never see those burst into flames.
But yeah, so
okay, cool. Thanks for that tip. Yeah. What do you have next?
The other thing is, so I do a lot of MIDI stuff, as you are aware. I also do a lot of stuff with the little cutie pie or Zhao boards, and so I've been whipping up a combination MIDI BFF. It's a MIDI interface in and out, both the big old MIDI interfaces and the new little TRS interfaces, with a little display, and then 2 ports for a Zhao or a cutie pie. This is a Zhao in this case, and so now you've got a full USB MIDI interface. If you want it to be, you can also like one of the things I'm using it for is I'm doing it. You making this a MIDI thinner. Like some devices will kind of just spit out way too much MIDI information.
Data.
And like, for instance, CircuitPython gets a little choky when it's given too much interface. And so currently this thing's wired up as a thinner router.
Oh, that's
so
nice.
if it gets too much pitch bend, too much control information, if there's sysx, it'll filter all that out.
Yeah. Oh, that's a nice idea.
So yeah. So hopefully this will be in my store at some point.
And you have an extra spot there to put any little BFF that you want for.
Yeah, like I was thinking maybe a like a battery BFF.
Yeah.
So you could power this all by itself. But then maybe stick on one of those.
Now you need to make a boost converter BFF.
Exactly.
Very cool. And so those are going into your store. You said where? I know you used to have one on Tindy, and now there's a new contender.
Yeah, there's a whole hoopla with Tindy. Tindy's getting better. Tindy was kind of like offline and keeping people's money, but they seem to be making good on that. So my Tindy store is still around, but there's also a new company called smallrun.net that seems to be pretty great. It seems to be run by a maker also. So they're very responsive to changes. People are like, hey, what if the sword could do this, could do that, and so I'm having stuff on small run as well, and there's always electrons. If you're a maker looking to sell some of these sell some of these things, there are several options now for Etsy for electronics.
Yeah. Oh, that's great. Yeah.
Yep.
Cool.
Anyway,
We'll look
that's
for
it for me.
Thanks, Todd. See you. All right, next up we got Cooper. If everything is good on audio, what do you think? Let's see. Yeah, no, we're good. You got time. I'm seeing, but not hearing. Let's see. Yeah. I heard.
Okay, great. Sorry about that. Something's going wild. You know, it's those Mac OS updates, right? Anyway, so what I wanted to show off here today is many of y'all might be familiar with the Raspberry Pi video looper that y'all did at Adafruit. And I have here my classic, it's a little Raspberry Pi A+, and with a little screen on it. It's a lot of Adafruit stuff, etc. And I love this thing. You know, I play shows a lot, and a lot of time I have one of my artists, he loves like, oh, put on a speed run, right? Every time. So I have this thing loaded up with speed runs, and that's great. I love it. However, you know, this is kind of hard to replicate because, you know, there's Raspberry Pi, there's a bunch of, you know, boards in there, everything to get everything to work, and like software configuration. And I've always wanted like a solution that'll just work, right? That you just plug it in and you get going. And we have video here with the Raspberry Pi, the Adafruit Fruit Jam running on the RP2350. And I was like, well, how far can we push that, right? At least within CircuitPython. So what I did is I developed a video looper, but really it's playing through gifs because I don't believe we have MP4 decoding yet within CircuitPython. Maybe one of these days, we'll see. But yeah, so what it does is you just put a bunch of gifs in a folder on your SD card or within the flash of the device, and it just loops through those.
That's
just
great.
Very similar to the Raspberry Pi video looper.
Yeah.
Of course, lower resolution, lower frame rate. I need to do some more testing. I am able to do 320 by 240, but at like 3 frames, I need to test it. I think it's about 3 frames per second or so, which could be good in some situations, or maybe closer to 5. This program right now is running 5 frames per second. Classic Super Mario Bros. It'd be really cool if I was like, hey, we have Super Mario Brothers. Not yet. Maybe with Pico Game. We'll see. Anyway, so I think
that's great. Really yeah, so this is a really plug in this into your projection system at the venue and just let it loop kind of thing that is so much more forgiving than a full Linux computer, because the Raspberry Pi has always been a bit terrifying to use for those kinds of things.
Yeah, in this case, you'd probably just, maybe I'll have to work on this at some point, get a UF2 file, put it in boot mode, boom, pop it in there. And it's running. And now this is on the Fruit Jam, which I personally think is a little overkill for what I need this for. So I definitely want to look in like the next phase of this would be just basically a very simple RP2350 with an HDMI output, you know, no audio. I mean, there are buttons like I can change. In fact, I have a couple of other programs here that I can, you know, change.
I made that animation. That's funny.
Yes, I'm not surprised. I'm surprised. I pulled them from.
That was from like a Matrix display. Yeah, that's funny. No,
if you scale and everything too. Yeah, automatically.
Yeah, it seems like if you look at the Feather that has an HTX out, or even the Pico with the sock, now you're talking like $7 for a little video shank kind of thing. I love it.
And I could see, like, if you're doing an art installation, right? Maybe stacking up displays, or however you have it worked out. Now, if you need the power, you probably still need to set up a bunch of Raspberry Pis. But if you're okay with kind of lower resolution, which might be a vibe, who knows? You instead of spending, you know, 30, well, nowadays.
Yeah, now it's 120 when you're talking about like getting into a Pi. It's not 30 anymore. It feels like, I don't know what the cheapest is, but it's time to look at the microcontrollers.
I mean, this is the Raspberry Pi 1, right? Yeah. But the different format, A+, I think.
Yeah, so those were in the $20 range maybe.
I personally think that's totally adequate for this purpose. So you don't need a Pi 5.
It's funny because I was looking at for some of these like retro game projects I'm working on, I was like, oh, a Pi 4 would be good. Those are harder to find than a Pi 5. I've noticed. Like at least places I've looked, they're just kind of they've moved past that. The 5 is there, and the 5 is amazing, but the price is commensurate with the amazing. So it's like,
and I know power wise, it's not that bad, like power draw, but it'd be great if you could have even less, right?
Yeah.
So I can definitely see a bunch of feathers with this hooked up, one to each display, and you're done. And like you said, about $7 a piece, or depending. So I'll put in a little bit more work towards this, but I gotta say it was super easy in CircuitPython as always. It probably took me an evening and I was done. Right?
Oh, it's great.
Even though I'm sure there's utilities out there for like Arduino or something that you could push this faster, further, push more bits, etc. But it's not always necessary. So
it's good to push it. Good to push CircuitPython. Thank you so much, Cooper.
No problem. You have a great day. I'll share the repo in the chat.
Oh, you know what? Yeah, we got a moment. Do you want me to pop open this other window you had up?
If you want, it's just the GitHub,
it's a repo.
And it talks like, in this case, I've converted, like, I have a little script there to convert MP4 files into GIF format. The Super Mario one, I think, is about 1.5 minutes long.
Yeah.
And it takes up about 3 megabytes for the full resolution, and then like 1.5, etc. As you take the resolution down. All basic stuff. And it's available on FruitJam OS. Nice. And in the library as well, so you can download in FruitJam library. So
that's great. Is the GIF playback able to respect things like non-changing pixels not existing in subsequent frames? That was sort of more efficient size.
This is my first time utilizing, was it GIF.io, right? And whatever it does is what
I haven't looked at it, so I should look at it.
On-disk GIF is what this is primarily using. I'm not sure.
Yeah, because GIFs will do things where only the changed pixels will appear on subsequent frames just to keep the size down. But in like a long time ago, some things didn't want to play that, and they just wanted like every frame to be unique. But yeah, I'll have to look at that. Super cool.
That's a question for someone else other than I.
Well, thank you, Cooper.
Thank you, John.
Take care.
You too.
All right, and last up we got George here. Let me bring George on. Oh, things are moving. There we go. Hey, George.
Hello. How are you doing today?
Good, thank you. How about you?
Good. So I was thinking about this week a problem that I used to run into every once in a while, and I thought I'd share. Is when you're getting started in electronics, one of the things I love about electronics is that I can't think of a topic that goes so deep. You can spend a lifetime learning it, but when you start out, it's a little hard, especially with analog stuff, because you can't see electrons, you can't hear electrons. If you're lucky, you're working with a circuit that you have an input and an output, and you change a resistor on a 555 timer circuit, and the light blinks a little faster, and you go, oh, eureka, an input and output, I can see what I'm doing. But for a lot of circuits, you don't get that visual, indication or audio. And so you really have to trust your eyes and your ears to multimeters. And then there kind of comes a day when you're working on a project and you don't know if you can trust your multimeter. You say to yourself, wait, is it my circuit or is this thing messing me up? And so I thought I'd share with you just a couple little tools that I have that help keep me sane.
Great.
So I don't have to think about this. But here's a collection of some multimeters that I have. And if you're just getting started in electronics, you really just need one multimeter. You don't need a big collection. I have a collection because I've been doing this for a while. But I totally understand when you're first starting out and you're wondering, hey, is my multimeter reading correctly? Probably your best bet might be to get a second multimeter.
Oh.
And that way you can check one against the other. But if you want to take it one step further, there are some interesting little devices that you can get on eBay, which are basically just a bunch of resistors. And here, this one has some capacitors as well. And they're reasonably priced. I'm not over the moon about paying $12 just for some resistors. But what this person has done is they've taken a higher grade multimeter than probably what you have, and they've written the calibration of what their meter says.
Yeah.
And then so you can plug in your meter and read it and says, okay, are we about in agreement?
That's a great idea.
Right. Now, so you can go down the rabbit hole with this of calibrating to the nth degree. And, you know, the final say on this is the NIST, and there's a lot of transfer standards. And if you want to Google that stuff, that's a whole hobby in and of itself that people get into. I'm not that kind of person, but hey, if it's your hobby, that's awesome. And some people set up their entire labs with, you know, multiple meters and they have everything calibrated. I just want to know that I'm reading things kind of, you know, trustworthy. So that covers you for resistors and capacitors. And then of course with capacitors, you know, what's its temperature? You know, a lot of capacitors are plus or minus, you know, 10%. So it's a little different story, but that'll cover you with resistors and capacitors. And then for voltage, that becomes a little bit trickier thing. And so there are some sellers that sell these voltage standards, and it's a pretty simple device. It's actually kind of clever. We can talk about this if you want, just briefly. It uses an old, I believe these are digital camera batteries. So this unit is actually rechargeable. It needs power, but I just thought it was funny that they were repurposing some old technology. But what this person has done is they've with a more expensive multimeter, they've measured the values, and if you press the button once, it'll give you 2.5 volts. And we'll just go ahead and do a live demo here, so you can see we're reading about 2.5 volts, and the next measure is 5 volts, 7.5 volts, and 10 volts, and that gives you a nice little sanity check for your voltages on your multimeter. So it's some place to start. Like I said, you can really go down the rabbit hole of chasing calibration and calibration certificates and sending your equipment off, or buying a piece of equipment that has been certified. But that's a couple little tools that I use that aren't too expensive. This one's 12. The resistors are $12 about, and that standard, or that voltage measurement, is about 24.
That's really great. It's funny, I had never thought of, should I just trust this this meter? Because the case where I get into calibrating stuff often is with these DIY Eurorack synthesizers, where the calibration process is feed it a volt and then adjust pots until that volt sounds like, you know, middle C.
There you go.
Am I feeding it a volt, or am I not feeding a volt?
Well, there's more than one way to do it, for sure. So you can test it with another multimeter. You can have a standard, you know, but that's interesting. The musical world has its own flavor of
musical plus electronic world. So you a couple of deep dives there just to make that work. Oh, that's really great.
Right.
Well, thank you, George, for sharing those. Please come back with more tips like that. That's really a great format for learning about that. Appreciate it.
Will do.
Okay, take care. All right, and that is going to do it for tonight. Thank you, everyone, so much for stopping by. If you want to check out any of the things that people mentioned where they said they would put a link in the chat, that's probably going to be over on our Discord chat, so you can head over to adafruit.it/Discord, look for a live broadcast chat channel on that server there, and you can ask also if there's anything you want to see. I see that Cooper just posted the video jam, Fruit Jam video looper, and I'm gonna check that thing out. That looks great. Okay, thanks everyone so much for stopping by. I'll be back tomorrow at, I don't mean to point, but I'll be back tomorrow at 1 o'clock Pacific, 4 o'clock Eastern time with John Park's workshop to show you some of the stuff that I've been working on. So thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been Show and Tell. Bye-bye.